Earlier, when we were discussing about finding out the relationship between the roots and the coefficients of the polynomial, what we did was that for a polynomial ax square plus bx plus c, if alpha and beta are the roots, we have got x minus alpha into x minus beta with as the factors. And when we are multiplying them both, and I also told you what is the significance of k in this particular equation. When we opened the bracket, we wrote like this and we equated the terms on both the sides and we derived the relationship between alpha and beta. Correct? Now, you can see that this is a given polynomial. Alpha and beta are the roots, means the polynomial can also be written as x square minus sum of the roots into x plus product of the roots. Correct? So, whenever you are given the roots of a given polynomial without mentioning what the polynomial exactly is, and they are asking you to write down the polynomial, this is how you write it down. K into x square minus sum of the roots into x plus product of the roots. Let us do a few numericals based on this particular concept and see how we can apply it. I have written two questions over here. The first one is a find the quadratic polynomial whose roots are minus 1 by 4 and 1, and find a quadratic polynomial whose roots are 3 and minus 5. Can you tell me what is the difference between these two questions other than the fact that the roots given are different? In both the cases, you are asked to find quadratic polynomial and the roots are given to you. What exactly is the difference? When we do the sum, when I am solving for both these questions, I will tell you what exactly is the difference and how you should answer this in the question paper. See, in this case, alpha is equal to minus 1 by 4. Beta is equal to 1. Okay. What is the quadratic equation or quadratic polynomial when we are given the roots? As I told you, the quadratic polynomial is given by k into x square minus sum of the roots into x plus product of the roots. Okay. What is sum of the roots? Alpha plus beta is equal to minus 1 by 4 plus 1, which is a 3 by 4. Okay, and what is the product of the roots, which is alpha into beta, which is minus 1 by 4 into 1, which is a minus 1 by 4. Now let us apply it to the polynomial equation. You will get the given or the polynomial which is asked is k into x square minus sum into x plus product. Okay, now this is our given polynomial and k into x square minus 3 by 4x minus 1 by 4. That is our polynomial. Now, the question is find the quadratic polynomial. The k stays there in the answer. So, you will write this is the required polynomial and depending upon the value of k, we can have many polynomials. So, for example, when k is equal to 1, the polynomial becomes x square minus 3 by 4x minus 1 by 4. Clear? Now, in the second case, the question is find a quadratic polynomial, which means that they are expecting you to substitute one value of k and give the answer. For example, in this case, what is the value of alpha plus beta? Alpha plus beta is minus 2 and alpha beta is minus 15. Okay, so our polynomial is k into x square minus sum is a minus 2 plus product. So you will get k into x square plus 2x minus 15. Okay, this is not our answer. Our answer is find a quadratic polynomial. So we will say if k is equal to 1, x square plus 2x minus 15 is a quadratic polynomial whose roots are 3 and minus 5. Read the question properly. It is a difference of one small word over there. Find the quadratic polynomial and find a quadratic polynomial. After writing the general form, if they are asking you to find a quadratic polynomial, then you substitute the value of k as a 1 and then write it down. Okay? Find a quadratic polynomial whose roots are minus 1 by 5 and 10. See, this is similar to the questions that you can find in any of the reference book or the NCERT textbook. Now, I have already told you the difference between the questions find the quadratic polynomial or find a quadratic polynomial. Now all the question papers or all the reference book or the textbooks always mention a quadratic polynomial. To get a better clarity about this particular sum, let me write find two quadratic polynomials whose roots are minus 1 by 5 and 10. See, nobody will ask you this particular find two quadratic polynomials, but you need to understand what you are doing. Okay, now alpha is equal to minus 1 by 5, beta is equal to 10. So alpha plus beta becomes minus 1 by 5 plus 10, which is actually minus 49 by 5. Correct? Okay. Now, what is alpha beta? Alpha beta is minus 1 by 5 into 10. So, when you are cancelling the common factors, you get a minus 2. Our polynomial is k into x square minus sum into x plus product. This is our polynomial, general form of the polynomial. Now, depending upon the value of k, we can have multiple polynomials is what I told you. So, let me rearrange it. Sorry, I think I have made a mistake here. It is a plus 49 by 5. Right. Okay, because minus 1 by 5 plus 10 is a plus 49 by 5. So, x square minus sum into x plus product. Okay. Now, when k is equal to 1, what happens to the polynomial? The polynomial becomes x square minus 49 by 5 into x minus 2. Okay. Now, in order to get a better feel to the polynomial or to put the polynomial more neatly, what we normally do is that we eliminate the denominator. When I say eliminate the denominator, basically what we do is that suppose this polynomial is represented as q of x or p of x or f of x, whatever, is equal to x square minus 49 by 5x minus 2, correct? I need to eliminate y. For that, I need to take the LCM. When I am taking the LCM, I need to take it across. So, if I am multiplying by 5 across, you will get 5 into qx is equal to 5x square minus 49x minus 10. Correct? I am multiplying all the terms on the LHS and on the RHS. This 5 into qx is again a polynomial. Correct? So, let me call it as a px. Px is equal to this. That is what happens when you are having a fractional term in the polynomial and suddenly when you look at the answer, this denominator is not there. They are not cancelling the denominator, they are taking the LCM, and because this particular part is not visible to you, you are seeing only this part. So, you don't have to bother about whatever is not mentioned in your textbook, but understand it for better concept purposes, and this you can write it as 5x square minus 49x minus 10. So, that is one polynomial. When k is equal to 2, what happens? 2x square minus 98x by 5 minus 4. Okay, so again when I am taking the LCM, this becomes 10x square minus 98x minus 20. So, I have got two polynomials. So, I hope you are clear with the difference between the general form of the polynomial, and when you are substituting k is equal to 1, we get one polynomial. We initially got it with a fraction. If we are getting it with a fraction, take the LCM of from the denominator and multiply across. When k is equal to 2, this is what you are getting. So, normally in the question paper, you normally get find a quadratic polynomial. So, what you need to do is that you will write till here. Okay. After that, you will write when k is equal to 1, the polynomial becomes this. Okay, this and this you will write. So, the final answer will be this. I hope you are very clear with this. So, let us do one more sum and wind up this particular type of sums. Find the general form of quadratic polynomial is the first part, and find a quadratic polynomial is the second part. the roots are given to be root 2 and 1 by 3. So I will just write down the steps properly so you know what exactly to write when the question is being asked. So alpha is equal to root 2 and beta is equal to 1 by 3, where alpha and beta are the roots of the given polynomial. Now, alpha plus beta is equal to root 2 plus 1 by 3. You are not expected to substitute the value of root 2 and calculate. You can just leave root 2 as root 2, and alpha beta is equal to root 2 by 3. Okay, now general form. K into x square minus sum into x plus product. Okay, so k into x square minus root 2 plus 1 by 3 into x plus product. Then you will write depending upon the value of k, this is a general form, and depending upon the value of k, we can have many polynomials. Okay, now the second part. Find a quadratic polynomial. Suppose that is a question that is asked. You will write the general form and then you will say k is equal to 1. Polynomial becomes x square minus root 2 plus 1 by 3 into x plus root 2 by 3. Okay, now we need to take the LCM in order to eliminate the denominator, the LCM being 3. So what we will do is that x square, now root 2 plus 1 by 3 is equal to 3 root 2 plus 1 the whole divided by 3. Correct? And root 2 by 3 is a single term, so I am leaving it as such. So basically our polynomial is x square minus 3 root 2 plus 1 by 3 plus 2 by 3. Okay. After that you will write, because we need to take the LCM and make it neat, you will say the required polynomial is, take the LCM, 3x square minus 3 root 2 plus 1 into x plus root 2. I hope you are very clear with how to present the answer and how we have got different answers for general form and when we are substituting the value of k, and it is not necessary that you need to put k as 1 itself. You can put k as 3 directly and then eliminate the denominator. Doesn't matter, but then most of the books, most of the textbooks and even your teachers may always be used to putting k is equal to 1. So do not take a risk when you are writing the answer paper. If alpha and beta are the roots of the polynomial f of x is equal to x square minus x minus 2, find a polynomial whose roots are 2 alpha plus 1 and 2 beta plus 1. Okay, so we have a polynomial f of x is equal to x square minus x minus 2 and alpha and beta are the roots, means what is alpha plus beta? Alpha plus beta is minus b by a, minus of minus 1 by 1 which is a 1, and alpha beta is minus 2. We need to find the polynomial whose roots are 2 alpha plus 1 and 2 beta plus 1. Okay. So this part is given to you. Now the roots of the second polynomial which we need to find is 2 alpha plus 1 and 2 beta plus 1. So you know that the equation of the polynomial is k into x square minus sum of the roots into x plus product. So sum of the roots in this particular case is 2 alpha plus 1 plus 2 beta plus 1. So you will get 2 into alpha plus beta plus 2. Correct? If I am taking 2 outside again, you will get 2 into alpha plus beta plus 1. But we already know the value of alpha plus beta, which is a 1. So when I am substituting it, I will get 2 into 2 plus 1, which is 2 into 3, which is 6. Okay. Now the product of the roots is 2 alpha plus 1 into 2 beta plus 1. So let us see what we are getting. Right, we need to open the bracket. So you will get 4 alpha beta plus 2 alpha plus 2 beta plus 1. So alpha into beta is a minus 2. 2 alpha plus 2 beta is actually 2 into alpha plus beta, which is 1 plus 1. So when I am substituting minus 8 plus 2 plus 1, which is a minus 5. So I am getting the sum of the roots as a plus 6 and the product of roots as a minus 5. Now first let us write the general form and then we will substitute k is equal to 1 in order to get one polynomial. Okay. I have made a mistake in finding out the sum of the roots, which is 2 into alpha plus beta plus 2. When I substituted the value of alpha plus beta, I had to substitute 1. I substituted 2. So this is 1. So the sum is a 4. My bad. Sorry. So now let us write down the polynomial. So here you can see the general form I have written k into x square minus sum into x plus product. I have written the sum 4 minus product. Now when k is equal to 1, we get one polynomial or the required polynomial as x square minus 4x minus 5. I hope you are clear with this sum also. I hope you are clear with the sum. So now let us do a couple of more sums and wind up with this part. Let f of x is equal to x square minus 2x plus 3. If alpha and beta are the roots of fx, find the polynomial whose roots are given by alpha minus 1 by alpha plus 1 and beta minus 1 by beta plus 1. So as I have told you, whenever you have a polynomial, identify a, b and c and write down what is alpha plus beta and what is alpha into beta. So x square minus 2x plus 3 alpha plus beta is equal to minus b by a, minus of minus 2, which is a 2, and alpha beta is c by a, which is 3 by 1, which is a 3. Okay. Now we have to find the polynomial whose roots are this and this. In order to find that, the equation is given by k into x square minus sum into x plus product. We need to find the sum and the product. So what is the sum of roots? That is alpha minus 1 by alpha plus 1 plus beta minus 1 by beta plus 1. Okay, slightly complicated. In order to proceed, we need to take the LCM. So alpha minus 1 into beta plus 1 plus beta minus 1 into alpha plus 1. In the denominator, you have alpha plus 1 into beta plus 1. Okay. Now let us open the bracket, basic binomial multiplication. So you will have alpha beta minus alpha plus beta minus 1. And here you have alpha beta plus beta plus 1. So now let us see whether we can cancel off any of the terms in the numerator or denominator. Alpha beta and alpha beta will give you 2 alpha beta, plus alpha minus alpha cancelled, minus beta plus beta cancelled. Minus 1 plus minus 1 is a minus 2. And you have alpha beta plus beta plus 1. Now let us substitute the values from here. Alpha plus beta is 2 and alpha beta is a 3. So you have 2 into 3 minus 2 by alpha beta is a 3. So you will get 6 minus 2 is a 4 and here you have 6. Okay, we can reduce it because 2 is a common factor. So you will get it as 2 by 3. Okay, so now we have gotten the sum of the roots as a 2 by 3. Now let us see what we are getting the product as. Here I have found the product of the two roots. Again binomial multiplication. So when I am opening the bracket, this is what I am getting. In the numerator, alpha minus beta. Minus sign is a common, so I have taken alpha plus beta here. And when I substitute the value, finally I am getting 1 by 3 as the value of the product and 2 by 3 as the value of the sum. Now let us substitute these values in the general form of the polynomial and then substitute k is equal to 1 in order to find a particular value of the polynomial. Sum of the roots we got as 2 by 3 and the product as a 1 by 3. So general form is k into x square minus sum into x plus product. So you can write it here as general form. And when k is equal to 1, this is what we are getting. So the required polynomial after taking the LCM is 3x square minus 2x plus 1. Okay. So now we have done, a few sums and I hope you have gotten a very clear idea about how to form the polynomial when the roots are given to you.